All right, so for this function, we're going to find the intervals where f is increasing, going up, where is it decreasing, going down, the concavity, is it concave up or concave down, and the inflection points, the points where it changes concavity. So to find the intervals where f is increasing and decreasing, we take the first derivative. 12x cubed minus 12x squared minus 24x. We want to know when this is 0 or undefined. This is a polynomial, so it's defined everywhere. We don't have like a fraction where the denominator could be 0. Yeah? So we just got to solve this. If I factor out a 12x, I'm left with x squared minus x minus 2. This factors 2x minus 2, x plus 1. Again, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. When is this 0? When each factor is 0. This 12x is equal to 0 when x is 0. X minus 2 is equal to 0 when x is 2. And x plus 1 is equal to 0 when x is negative 1. So these are our critical numbers, our critical x values. So now we want to draw our little number line and see, putting these in order, negative 1 is first, 0 is the next, and 2 is the biggest. And we want to look at the first derivative of f. So pick a number less than negative 1. Oh, I don't know, negative 5. When I plug in negative 5 into the first derivative, I like to use the factored form, because 12 times negative 5 is a negative. Negative 5 minus 2 is another negative, and negative 5 plus 1 is another negative, and when I multiply 3 negatives, we get a negative. If I pick negative 1/2, 12 times negative 1/2, a positive times negative is a negative. Negative 1/2 minus 2 is a negative, but negative half plus 1 is a positive, and a negative times a negative is a positive times a positive is a positive. Plug in 1, positive, negative, positive, multiplied as a negative. Plug in something bigger than 2, like 5, where all 3 are positives, and 3 positives multiplied as a positive. So therefore, f is increasing where the derivative is positive, that's where our function is going up. So it's increasing on negative 1, 0, and on 2 to infinity. Now I tend to use parentheses because right at negative 1, that's where our function is changing from going down to going up. So right at that point, it's not going down and it's not going up, it's where it's changing. So I'm not going to include that. Where is f decreasing? That's where our derivative is negative infinity to negative 1. And it's also negative between 0 and 2. Right? We could also identify our maximum and minimum values. Like I said here, when it changes from a negative to a positive, f is going down and up, down and then up creates a minimum. 0 is going to be a maximum because f is going up and then down, that creates a maximum. Negative to positive, just like here, is another minimum. So these are our relative minimums and 0 is our relative maximum. But we weren't asked to find that, but I just wanted to mention that. Now what about concavity? Well, that's our second derivative. So we calculate the second derivative. I'm going to first rewrite the first derivative. I'm going to factor out a 12. So the first derivative is 12 times x cubed minus x squared minus 2x. And we want to take the derivative of this. Well, to take the derivative of this is just going to be 12 times the derivative of that. Why? Think of the product rule. First times the derivative of the second. The second times the derivative of the first, well, that's going to give us 0. Yeah. So all we got to do is take the derivative of this, 3x squared minus 2x minus 2. When is this 0? Well, 12 is never 0. So we want to know when is that 0. Well, that does not easily factor. So let me just erase this, keeping in mind we're finding the concavity and points of inflection. So we got to use the quadratic formula. So the solutions to this quadratic equals 0 is the opposite of negative 2 is positive 2. Negative 2 squared is 4 minus 4 times a, which is 3, times c, which is negative 2. All over 2 times a. And what do we get? 2 plus and minus the square root of 24 plus 4 is 28 over 6. 28 is 4 times 7, and the square root of 4 is 2. So we get 2 plus and minus 2 root 7 over 6. If I factor out the 2, well, I'll do this step by step. 2, so we get 1 plus and minus root 7. 6 is 2 times 3. So the 2, this 2 cancels with that, and we get 1 plus and minus root 7 over 3. Now let's get a numerical value to get a rough idea to visualize this. The square root of 7 is about 2.6 over 3. So what do we get? 3.6 divided by 3. If you plug that in your calculator, you're going to get about 1.2. And 1 minus 2.6 over 3, plug that in your calculator, whatever, and you get minus 0.5, about. These are approximate values. Yeah. So, now what about the concavity? Well, the concavity has to do with the second derivative. So our second derivative is, our critical numbers for the second derivative is minus 0.5 and 1.2. And we want to look at the sign behavior of the second derivative. So I erased it. Let me find the factored form of my second derivative, or the second derivative, if you recall, is 12 times 3x squared minus 2x minus 2. So here's our second derivative. When I plug in a number less than negative 0.5, let's plug in negative 1. We get 3 minus a minus 2. 3 plus 2 is 5, minus 2 is 3, times 12 is a positive. 0 is a nice number to pick between a negative and a positive. When I plug in 0, we get 12 times negative 2 is a negative. And when you plug in like 10, you're going to get 300 minus 22, which is going to be a positive. And we get a sign behavior. Now, the inflection point, you got to do this to make sure the sign changes. If the sign doesn't change, it's not an inflection point. That we do see the sign does change for both of these. So x equals minus 0.5 and 1.2. Both of these are inflection points. All right, so now what about the concavity? Well, that's pretty easy. It's concave up, where the second derivative is positive, negative infinity to negative 0.5, and it's positive from 1.2 to infinity. And it's concave down, where it's negative minus 0.5 to 1.2. So that's the idea of maximums, minimums, increasing, decreasing, concavity, and inflection points.